Hello everyone, welcome back. Got some requests from a few colleagues. Recently some stuff has come up in my day-to-day job around dependency injection, how to do async inside of a constructor, and other sort of, let's try that introduction again, and other various things of that nature. So I started poking around, figuring, I was like, I'm sure I've done a video on this. Turns out I couldn't find one. So here we are, we're gonna do one. Few quick updates. Updates are good. Updates are very good. First, GitCon is happening. Yay, GitCon. So if you're not familiar with it, loud. This is GitKraken's online developer conference. It's completely free. If you want to grab it, you can check out their live stuff. Days 1 and 2 are already complete. Today was day 2. So if you're watching the recording of this video, you missed it. But day 3 starts tomorrow. So if anyone is interested, you can go to gitcon.com and you will grab the link there. You can go to their YouTube page. If you do register, they do have some prizes, drawing things that they are doing. So huzzah, if you'd like to sign up. But nothing stops you from just going and watching the stream on YouTube. If you are interested in my session, day 1, like 3rd or 4th one in. I don't remember exactly which, but it's there, I promise. Okay, on the note of that as well, we are going to once again pick up with the test project that I was poking around with last week. Specifically, it leverages one of my .NET templates. So we will be leveraging that. If you are looking for information on some of the kind of the generic DI stuff, we're going to cover a little bit of it, but this is going to be like DI V2. We'll call it slightly more advanced level stuff, because I think that's important to do. Material design. I want to make a quick comment on this as well. So the material design in XAML, the tree view did merge. That is in. Do not attempt to use it yet. Well, I should say this. The only way you're going to attempt to use it is if you clone the source. Unfortunately, the NuGet deploy key has expired. The owner of the repo said he'd get me a new one this week. So whenever that happens, we will be pushing out a new NuGet package with the 5.0 stuff. I'm going to write docs. We're going to see about getting the 5.0 release out the door. I keep finding little breaking changes that I want to sneak in. So I'm trying to balance how many breaking changes I want to put in versus how many docs I want to write on every breaking change. So we'll see. I thought about yanking the wiki in, and I might not. I had considered it because having the wiki as part of the repo has a nice perk in that people who can do pull requests against it. It has the disadvantage of you give up all of the navigation bits, and I'd have to redo every link. And I'm like, I don't know if I want to do that. The GitHub pages might be better. I don't know. So for now, it's going to stay as a wiki because I couldn't make up my mind. I went, you know what? Pain versus benefit, it seems too low, so we're not going to do it right now. Okay, so why do I have red squiggles? I'm going to restart Visual Studio because I do not know what the heck it is doing and why I'm getting red squiggles. I did just install a beta update because why not install a beta update right before streaming? What could go wrong? This is the problem with updates coming out on Tuesday and me streaming on Wednesday. There's a high probability that I've just installed an update prior to streaming. Either that or I'd have to show restraint and like not immediately take an update every time the little colorful bell shows up in the corner. I just love it so much. Okay, what are you squawking about? Cannot implicitly... Okay, something has clearly gone wrong. And it would not shock me to find that it is in the SDK. But you know what? I think it builds still, so we're just going to ignore the red squiggles and move on, I think. I just want to... Yeah, rebuild all successful. So yeah, despite the fact that Visual Studio reports a compile error, it builds. So great. Okay, so quick recap to get everyone up to speed. This is my WPF template that uses the generic host as a means of bootstrapping your WPF. Specifically, it uses this create host builder, which anybody who has gone through like ASP.NET Core or ASP.NET latest stuff, .NET 6, .NET 7, soon to be .NET 8 next month, will be somewhat familiar with. It gives you a nice, easy way of doing the configuration. And it also lets you, inside of your WPF app, leverage anything that's built on top of the Microsoft dependencies abstractions. There's a lot of stuff out there. If you want to use a different DI container, any of that stuff, any of the mainstream ones that are worth your time considering have integrations here. So it makes it a very nice way of doing the registrations. It builds it up. And the key line is this main window here, which when you call get required service from an I service provider, that is telling the DI container, please create me one of these things. In this case, main window. Now, the default DI container, the Microsoft one, does not have magic. Some DI containers do this reflection stuff where they'll scan the assemblies and they'll do various things. The Microsoft one, it's pretty simple. If you don't tell it about it, it doesn't know about it, and it will throw up its hands and give up. So in this case, we've told it, hey, main window, I expect it to be a singleton. Right? This is something called lifetime. We'll get into more in a minute, but singleton means you get one of them. Think of it creating like a static instance. The big difference between just using like the static singleton pattern and going through something like this is now main window is ignorant of its lifetime. It could be one, it could be single. It doesn't know, it doesn't care. And more importantly, app doesn't necessarily know. I mean, it kind of does because of this, but this could be off in another, this method here could live in another class or similar. But our main one doesn't necessarily know. It just knows that in order to start this app, it needs to get a main window, needs to make it visible, and off to the races we go. Down in here, this gives us a lot of flexibility, but it doesn't really expose a lot of this. And for my template, I tried to keep things simple. And the beautiful thing about simple is they're easy to understand. The problem with simple is that they don't always have everything that's in there. So let's go through and let's pick on a couple common use cases. So for example, main window view model, right? This thing's very simple. Let's pick on something like ILogger, right? Main window view model logger. Right, and then we will magically go through and include the logger, and then we will say logger, I don't know, assign there, and then every time we increment, we will do something like logger, log information, count is, I don't know, count. We'll do some advanced logging stuff here. We'll dive into it. Right, so we'll do the log message after we've done the increment. Yes, we could do this inside of here. That just makes it hard to read. We're going to do it like this. Okay, a couple things I'm going to call out with the logger right away. One, you will note that I did not immediately do $sign and pass count in like this. Right? Instead of doing that, because this would be straight string interpolation. If we look at log information, I don't have my zoomit in running. I don't have Karnak running. There we go. Get all the things going. If we look at log information here, we can see that the very first parameter, oh, it's so dumb it did that. First parameter is a string, which is fine, right? That's not the worst thing in the world. But if we do this and we look at it, we see that the first parameter is still the string, but we now have this param args that we're leveraging. And the idea here is something called structured logging. Not all loggers support it, but say you have something like Splunk, something or Siri loggers, one of the very, I guess I'm mixing things there. Say you have one of the other loggers in place that wants to do some sort of intelligent logging, because quite often what you want to do when you are hunting your logs is say, find me all of the instances of the message count is. Right? You don't necessarily care what this value is, but you want to find all instances where this log information was called, and you know that this count is going to be a variable. With structured logging and an appropriate logging provider, it gives you the ability to make those types of queries. And then it can do fancy stuff around saying, oh, okay, let's find where count is greater than 5. Only show me those log messages. Because we've separated out the value from the string, now the logging provider knows that, okay, I've got a variable here called count, a value that's passed in called count, and just to make a point, int gets count, right? It's not matching on name. And this is positional. So you could almost think of this as the equivalent of a string format where you do index 0. But in this case, we give it a name because names are useful. And you should always give your parameters names that make sense and are indicative of what they're going to be. So we will go ahead and do this log information. And then I just want to prove a point. So we're going to fire this up. And of course it opens on the wrong monitor because that's what it does. Okay, now when we click this button, boom. Okay, we can see that logger was appropriately populated, right? And we have the type of this logger is Microsoft.extensions.logging.logger, but the generic type is main window view model, right? Exactly what we specified here. Okay, that's cool and nice. We're going to go ahead and log count. And then I think at this point, we now have a little log message in our debug output, right? Information level count is 1. Huzzah. Right, so what actually enabled this to work? So something that is not in the template that I kind of secretly snuck in is I added in this services add logging here. And this does a whole bunch of work for us, which we'll look at in a minute. But one of the thing that's worth being aware of is if you just do add logging, you get some defaults out of the box. Great, we're off to the races. If you look at this overload here, logging builder, we can do this and we can go logging builder, and we can come in and we can start to add in different loggers. You can see there's add console, add debug, add event log. We can put in adding in different filters to be able to filter different category logs. We can do a JSON console. There's a lot of readers, like adding JSON console is common inside of like a Kubernetes thing where it's going to write out to the standard out, but it's going to do it in a structured JSON format. That way, any of those structured loggers that are watching standard out can pick it up, which is a great interop way of doing it. There's simple console, system D console. You can clear all the default providers. You can set a minimum level. All of this stuff, right? That you can theoretically go through and configure if you want. But what's most interesting here, in my opinion, is the fact that we registered ILogger of T. We registered an ILogger of T. So let's just play around with what that ends up needing to look like. All right. So let's imagine we had a public interface of an ifoo of T. Right. And we wanted to come into main window view model and we wanted to do ifoo of main window view model. Right. And we'll call this thing foo. We're just going to put a breakpoint here for purposes of looking at it. Now, if we run this right now, what should happen, right, is it's unable to resolve ifoo while attempting to create a main window view model. Great. How did we get here? If we look at main window, main windows constructor requires a main window view model. If we look at main window view models constructor, it takes in the ILogger and the ifoo. Our DI container is not brilliant. It literally is just walking through the constructors going, what do I need? Do I know how to build that? What do I need? Do I know how to build that? That's it. Nothing fancier than that. And it gets to ifoo and goes, I have no idea what to do with an ifoo, right? Especially an ifoo of T. Because normally what we would do is we would have an interface of ifoo, right? And maybe a class, public class foo. And then we might do a registration here of something like services. Let's do add transient. So we get a new instance every time. And we'd go map ifoo. And the implementation of ifoo is just going to be foo. Oh, and foo cannot be used because foo actually has to implement ifoo in order for this to work. Great. Huzzah, we're off to the races. And now if we go to main window view model, we should be able to resolve this guy now and have him magically work. Boom. We actually got a foo instance. Huzzah. That's what we like. Okay, but now what if we want to do a foo of t? Right? So this becomes foo of t, and this becomes foo of t. Right? We can do this type of registration here, but how do we do ones with generics? So the thing to be aware of is add singleton, add transient, all the helper methods on iService collection, these generic ones, these are all helpers. Right? If we take a quick gander inside of here, we can see that the add transient method does some checks and then comes in here and goes add transient and comes in here, and we can see that it calls add again. And we get all the way down to this add method, and all it is doing is creating a service descriptor and adding it to the collection. Okay? iService collection is literally a collection of service descriptors. That's it. And a service descriptor is not a very complicated class. It has a service type, and then it has one of several things. So there's your service type, there's your lifetime. Lifetime is the ones that you would expect. Singleton, scope, transient. Ignore the fact that it doesn't have a default one. That bothers me, but whatever. So it has a key and a lifetime, and then one of these three guys is going to be done. Right? Either the service type will be mapped to an implementation type, or it'll be mapped to a specific instance, or it'll be mapped to some sort of callback delegate for a factory to be able to create. So it's going to be one of those, right? And that's it. It's no fancier than that at all, right? So if we go back, what that means is ILogging was able to add in something that was generic. Why can't we? And so the way you end up doing this when you need to do generics is you can actually, dang nab you Copilot. See, this is the problem with Copilot. It's spoiling the end, jerk. There are overloads for add transient that do this, but I actually don't want to do that, right? Service descriptor. Typing's hard. Transient. Right? I'm going to do this instead. There, Copilot. See? And we're just going to call add directly. So, if you want to, and if you're doing open generics, I mean, you have to, you can register up something in your DI container using what is called an open generic. So in C#, you cannot do generic parameters, which is what these things inside the little alligator braces are. Or for those of you who played Pac-Man braces. If you want to specify a generic type and you don't care about the generic type parameters, you can create what is called an open generic where you just omit them. And the only time this kind of open generic syntax is allowed is inside of a type of. Trying to confirm if that's actually correct. I don't know of a situation where you can do an open generic outside of a type of. I think that might be the only instance. And the idea here is this is going to return a system.type object that represents what a generic will be, but the generic parameters are just going to be, backticks 0. You haven't told it what type it is yet. So this says, okay, for all instances of ifoo, go ahead and create me a foo of t. That's great. That's what we want. And now what we can do is we can come over to main window view model and we can go main window view model. And if we launch this guy, huzzah. We now get a foo. See if I can. Oh, wish there was a way to say keep that open. Man, I'm gonna have to set up a macro or something that zeroes in on that really quick. But this will go through and do and create that open generic, and now it will resolve it. It's wonderful. We're getting one step closer to how ILogger works. So if we go and take a look at add logging, we can see that it goes through and does something very similar. It does services triad, which is similar to calling add in that it'll first check if something's already registered and skip. That way multiple calls don't end up duplicating. And then it goes, okay, let's go ahead and register a service descriptor that's a lifetime of singleton. And we're going to map the open generic of ILogger of T to logger. Great. Perfect. That's what we expect. But then we also see that there's this logger factory. It's like, hang on, something's a little off here, right? Like at the end of the day, this logger of T has to somehow do something with that T. Let's take a look at what it does. So if we look at logger of T, we'll note that logger of T, its constructor takes in an ILogger factory. And this is a very clever trick. The factory comes into the logger, and the factory actually creates this ILogger instance. So the base of ILogger of T is in fact ILogger. And ILogger just has a few simple methods on it for log a message, is enabled, and begin scope. And most of the time you don't use these methods directly. You're going to use one of the extension methods on ILogger, like what we did, where you call something like log information. You'll know this is an extension method here. Because most of the time you don't want to have to specify every little detail of the log message. You just want to log a log message, move on. And so inside of logger of T, the ILogger factory calls create logger, and this T parameter ends up just being the category for the log messages. So you can see it's doing create logger, and it's passing this category name. And now it's got this whole type helper where it tries to come up with a reasonable display name, and apparently I can't navigate to the type because that would be useful and simple. Well, let me go that way. Ha. Joke's on you, I can still get there. Where it's going to go through and basically use reflection on the type to figure out a reasonable string representation of the type, because who knows, it could be generic, it could be an array. It's not as simple as just type.name. Good, for good reason. It should be slightly more advanced than that. And it's got some well-known dictionary stuff for the keywords to make those appear appropriate. Great. Huzzah, we love that. So in order for this to work, when you put ILogger of T, or in our case, ILogger of main window view model, what ends up happening is that because we have the open generic of ILogger mapped to logger of T in our DI container, it goes, I got you. In order to create the ILogger of main window view model, I create a logger of main window view model. Okay, and once again, the DI container then looks at the constructor and goes, okay, what do I need to create a logger? I need a logger factory. Great. I already know where my logger factory is. It was mapped from ILogger factory maps to logger factory. Great. I get my logger factory. I come in here and I say, okay, factory, create me a logger and use T, main window view model, figure out its display name, and create me an ILogger instance. And now this logger of T implements ILogger of T, and ILogger derives from logger. So this is one of those fun cases where logger of T both implements an interface and wraps an instance of its base interface, which gets interesting, right? So down here, when we log a message, all it's doing is it's done explicit interface implementation, because you'll note it has this ILogger before each of the method names. And then it just forwards those calls into its wrapped logger implementation that it has. This is a very clever way of using a factory pattern and an open generic registration to make the consumption of it very trivial, but then be able to still do some factory stuff to make sure that the logger instance that's built up has all of the needed bits, right? It needs to get to the various providers, because it could be shelling out to that JSON console, the systemd console, whatever is in there. It could be going to a file or whatnot. So that is how you register up open generics inside of your DI. Now, next, the things that I've set up here either have a lifetime of transient or they have a lifetime of singleton. But there is another choice, as what we saw on that enum, right? So we have services add scoped. Well, this is fun, right? So let's play with a scoped instance real quick and see what is the point of this. Inside of ASP.NET Core, the framework for ASP.NET Core leverages what I am about to show you to create a scope every time a request comes into your service. That's great. It logically kind of makes sense to us. Each request should kind of be handled within its own, trying to define scope without using the word scope, in its scopy thingy, in order for some level of isolation. But inside of WPF, WPF was invented long before this whole host builder thing existed. Therefore, it has no concept of this. So if we want to use scopes, we can, but the framework isn't going to help us. WPF is going to give us no help. We got to do it ourselves. That's both its blessing and its curse. WPF says, do it yourself. And we go, fine, fine. This is why other libraries exist to handle the do-it-yourself parts. Okay, so let's go into main window view model and let's do something like public interface I counter service. And I don't know, it's going to have increment. But you should spell increment correctly because that's important. And then we will do a public class counter service I counter service. And then we will implement it. And it's going to be a terribly complicated implementation. Private int count, and I think this should just return count plus plus. There's a subtle fun thing here, but we'll do it. Okay, don't worry, there's Mountain Dew in that cup. Let's see, I counter service. All right, so we'll go here and then down inside of this, rather than doing count plus plus, we're going to do count gets counter service increment. All right, simple, straightforward. Everyone's happy. Let's go back over to here. We're gonna go ahead and register this guy up. Services add scoped. I counter service. Boom. Okay, launch. Okay, we click. It doesn't work. We click. Okay, let's go fix that bug because it's going to annoy me real quick. It's going to really annoy me. Okay, spot the bug. 3, 2, 1. Okay, this is post increment, not pre increment. So what happens is count is incremented, but the original value is what gets returned. If you do a pre-increment, it will add 1 and return you the result. One of the few times where this matters. Click, there we go. And we go to 1 immediately. Huzzah. All right, there we go. So it makes sense, everyone's happy, poof. Reset. There we go. Okay, this is great. We've clearly gotten ourselves a counter service. It clearly knows how to count. Not that impressive. Let's deal with this scoped thing. So in order to leverage scopes, somewhere you need to pick up an I service scope factory. Let's see, scope factory. That sounds great. Now, this is something that you get for free by leveraging the generic host. Because you'll note I didn't have to register that anywhere inside of here. This is one of the things that comes in for free because you want to be able to manage those types of lifetimes. Just like I didn't have to do anything in order to have singletons and transients work, this scope thing comes in because in order for scope to work, it has to exist. Now, inside of here, what I can do is I can go scope factory, create scope. Right, and this returns var scope, which is... This returns me a service scope. Now, a service scope is a very, very simple thing. It's an iDisposable interface, which means we should wrap it in a using statement to clean it up. And all it has on it is a service provider. That's it. All right, so if we come in here, what we can do is... One, we'll put this guy in a using statement. And I'm gonna do this style just to be real clear on what the scope of this scope is. And now down in here, rather than using counter service, go ahead and move these guys up. I'm going to do scope dot service provider dot get required service I counter service. We will go with var counter service. Okay, and then we are going to, rather than using our property, we're going to use this instance of it. So when we fire this guy up, and yeah, it's squawking at me saying, hey, dummy, you could use the other using syntax. You know what? I don't care. I don't care. When I click the button, I get a 1. When I click the button again, I get a 1. I get a 1. I get a 1. I get a 1. Okay, what's going on? Let's take a look. So if we come in here, we click the button, we can see we have a counter service, and if we look inside of it, we can see that the count on this guy is 0. It currently doesn't have a count. So when we increment it, it goes to 1. And if we look at this counter service, we can see, okay, it's got a count of 1. And we come down here, we log it, great. And the next time we come in here, we see the exact same thing. We have a counter service with a count of 0 because we haven't actually called increment yet. We look at it again, it's now incremented to 1. Our count is always just being set to 1. The idea here is when you call create scope, anything that was registered in your DI container as scoped is going to the service provider inside that scope is going to be returning you new instances. Now, this service provider here isn't limited to just items that were registered as scoped either, because it basically gets a child service provider, might be the best way of saying it. So for example, we have a messenger. All right, so stop it. We're gonna go here. Let's do, well, actually we can pick up ILogger. ILogger of main window view model. All right, so let's grab that and look at a logger. Boom, boom, boom. Let's take a look at this guy. We come in here, we click the button. We got ourselves a logger instance. Now, more importantly, if we come in here and do something like reference equals, and I'm going to pick on lowercase logger, and then I'm also going to pick on uppercase logger. So the local variable here that we retrieved from the service provider in our service scope, and then the one that came in from our main Windows constructor are in fact the exact same instance, because ILogger was registered as a singleton and it has the same generic type, so the same instance is retrieved when we ask for an ILogger of main window view model, regardless of whether we're inside of a scope or whether we're inside of here. So inside of WPF, or anytime where you're using this, you can leverage a service scope oftentimes when there is a chunk of processing that you would like to do, and you potentially want to do some cleanup afterwards, is oftentimes where it doesn't really make sense to have, well, you either need isolation because of the resources being used. Maybe it's EF with like a DB context that you want to have separate instances of. Maybe it's some sort of service that's holding on to some state that you want some instance of. Because if everything works as a singleton, that's fine, but sometimes you want slightly different things. You could imagine in a WPF app, if you pop up a window that lets the user do some processing, maybe you want to register that window and its dependencies as scoped, so that when you pop it, each of those windows has its own scope. The key thing here is you just have to request, you have to, one, get yourself an iService scope factory. You have to create the scope. That's the important part. And more importantly, you have to dispose of the scope. So you have to be in charge of the lifetime. In ASP.NET Core, they manage the lifetime to make it the life of the request. And they just resolve everything from the scope service factory. That's where your controllers ultimately get instantiated from, is an iService provider that's from a service scope. That's how you end up getting those things, and you don't have stuff stepping on all of each other. So it is up to you to decide what makes sense in a scope and what doesn't. In general, I start without scopes and register everything transient or singleton. And then I will bring in a scope if there is something that makes sense. For example, I was working with a colleague. He was basically building kind of this data pipeline stuff, popping an item off a queue, running it through a bunch of processing, grab the next item, rinse, repeat. Right. So what he ended up doing was creating a scope that wrapped the processing of an item, so that after he popped an item off the queue, creates a scope, resolves all of the needed services for processing that item inside of a scope, does that work, throws it away, and away you go. And that way he didn't have to worry about any sort of kind of crosstalk or data sharing between the processing of separate items. Again, it's up to you. Your domain will dictate what makes sense. The other thing that's worth noting about is if we do something like, I don't know, iDisposable, right? This guy now needs to implement a dispose. And I'm just going to, I don't know, count equals 0. This is a really bad dispose method. Don't implement it like this. In general, you should implement dispose by following. So just to be clear, the proper way to implement disposable is to come in here and use the auto code that says implement interface with dispose pattern. This is the correct way to do it, just to be clear, because there are 4 different ways to implement iDisposable, depending on whether your class is sealed or not. Let's see, it's sealed or not, and whether you have unmanaged resources or not. Those are the 2 variables, and so you can imagine the 4 different kind of quadrants based upon the result of those. When in doubt, let the generator do this for you. Implement the to-dos. Keep what you want, keep what you don't want, right? We'll do it properly. We'll show the proper thing. We don't have unmanaged resources or large fields, so we're going to get rid of this. Disposed of managed state. Yeah, sure, fine, whatever. Right, we'll do this. And we aren't a sealed class, so it generated protected virtual. If we were sealed, it would end up generating private and non-virtual because it doesn't make sense otherwise. Okay, and then you'll note it also handles having a disposed value so that it's reentrant and all of that jazz. Excellent. Now, if we do this and launch, boom. If we go click, steps through, you'll note now when the scope dies, the scoped instance also gets disposed. So this is another good reason why you might want to use a scoped instance, is if you have a service that's disposable and you want to control when things get cleaned up. Again, it depends on if you have a logical bit for when to do the disposing. Let's see here. And I have to deal with fun people real quick. Stand by. As soon as I remember how to get back to my let's see. Boom. There. There. Sorry. Sometimes you have to do your own moderation. Okay. So, but again, key thing here, if you have a scoped service that is iDisposable, it will be cleaned up when the scope is cleaned up. So, controlling the lifetime of your services, another very good common use case. Okay, there's that, there's that, there's that, there's that. Okay. Let's continue poking on this counter service since I've got it here. Let's imagine, hypothetically speaking, that for this counter service, our increment is more interesting, and let's pretend like it's being saved off in a database somewhere, right? So our counter service is going to be persisting the count off in a database, and when we relaunch the app, we want the initial value of count to be loaded from that database rather than just always defaulting to 0. That way we can have some semblance of this. Actually, you know what? Let's actually implement that. Sure, why not? You know what? Because we can do this. Let's see. Await file. Write all text. Count.txt. This is bad code. Don't do this. Let's see. Okay. Boom. There. And then we're just going to make this task event, increment async, and we will change the interface. No, go away. Stop it. Stop it. Stop it. Stop it. Stop it. Increment async. There we go. What is your problem? Cannot await a void. Write all text async. There we go. Okay. So, and then let's imagine we have a public async task, init async. Right. So this guy here is going to go file, read all text async because the whole point of this is doing async stuff. We're going to do count.txt, right? String contents. And then we should probably await it because that was the whole point of doing that. If contents is not null and int.try parse contents out int starting value. All right, we'll go with count gets starting value. Okay, perfect. So now the problem comes. How and when are we going to call initialize async? The ideal situation here would be in the constructor, right? We'd go init async. Everyone's happy. And this kind of works. So demonstration. Except for the fact that there are compile errors and it doesn't work. Increment async. Await. Async task. Boom. There we go. Let's try this again. Okay. We increment. Yeah, we then crash because another thing is using it. So pro tip, you shouldn't click too quickly. But if we click again, is that actually writing? Count. Oh yeah, it's always writing a 1. Duh. If we close and nobody's calling init async, therefore, or I guess it is calling init async. So let's step into here. Contents reads a 1. Try parse contents. Count starts at 1. Great. Now when we come over here, when we do a click, it's just creating a new instance because we're inside of a scope. Count is 1. Great. Comes in here, increments to a 2. There we go. There we go. So now we are just stuck at 2s constantly. And back to 1 because we reset. Lovely. Okay, so that scoped instance is kind of annoying, but whatever. But this gets back to the point. Now, obviously there is a warning here. Because the call is not awaited, right? Nobody is awaiting on this call. This is technically a thing you can get away with. This is bad. Just to be clear. Bad, bad, bad. Don't do this. Because what happens if this thing throws an exception? Because the task is not awaited, where does that exception go? It can't go back to the caller. Because as soon as you hit this await, and this thing has to actually do something asynchronous, it's now off on a different thread. The first thread has finished the constructor and has moved on. So there's nowhere for the exception to go but up and out, which likely means you're crashing. Right? You're probably crashing at that point. And because no one's waiting the task, you might as well be async void. Again, don't do this. Also bad. Right? Because async void is blind, fire, and forget. What we would rather have instead is a way to say, hey, when we create this counter service, let's initialize it, but let's wait to move on until after we've actually been initialized. Because if we go fast enough, the constructor gets invoked as soon as we call get required service. And if we go fast enough, for example, if this thing takes a while, task.delay, I don't know, a second. Right? If we go fast enough, and actually I'm gonna change this a little bit. I'm gonna stop using the service scope for the moment, and instead we're gonna use the property so that we only get that way we get the top level instance. Again, this guy's still registered scoped, and so that you always have your top level scope. There's always the default scope or the top level one. Right? So if we click here, you can see we skipped right over 1 and went straight to 2. Right? And if we reset this guy, yeah, reset's all kinds of fun because clear and reset is just doing this, which isn't great, right? There's nothing's going back to increment async, so that's just going to keep counting. But because the first call went so fast, the initialization was slow. All right, so if we load this again, watch what happens. We're at 0, we click, right? And we jump immediately to 7. We reset, and then let's relaunch. All right, so 7 is what is saved inside of there. If we click, straight to 8. How are we getting an 8? I'm confused as to how we're getting that high. This guy should be delayed long. Oh, duh. It's because this thing is created immediately. Okay. So hang on. We're going to, because I'm not going quick enough. Time span from minutes. There. Darn it. I'm going to make this thing take a while. Okay. I'm trying to prove a point, and it's not helping my point. Okay. If I click, I now get a 1. And the reason I get a 1 is because I invoked an init async in my constructor. I did not await the task. This guy's off going to load data. You know, pretend like this is a database call rather than just reading from a file. But because this is asynchronous and nobody's awaiting him, no one has any idea if he's done. He's just off doing stuff. And then we come into increment async. Count hasn't actually been initialized. And now we run into this problem because we go, okay, we'll just increment count. Count goes from 0 to 1. And then at some point later, this guy's going to finish. I don't think we're going to wait 10 minutes. And he's going to read the file, come back and go, finally, we've got the initial value for count. And we're going to throw away everything that we had previously incremented and move on. Right? It's probably not going to be that bad because this write async is going to have the new value of 1. That's going to get written every time, blah, blah, blah. This guy will eventually be reading that file. Right? It could be worse, right? The order of operations could look like this. Like there's all kinds of ways we can make this go incredibly poorly. But the question then comes is when you need to do some sort of initialization like this, and we're gonna dial this down just to something a little reasonable for point purposes. If you need to do some sort of initialize async rather than your constructor, what should you do? Right? And there are a couple options you have available to you. One is this. This is bad. Another option is this. This is horrendously bad. In general, you should avoid calling .wait and .result on a task pretty much. You should do it never. Like bad, bad, bad. The reason is because you've now taken something that was intended to be asynchronous. You've now blocked it, saying, no, my current thread is not going to move on until this thing completes asynchronously, which means you're expecting that some other thread is going to go process this. So while that thread's processing, the calling thread is going to be blocked, sitting on its thumbs doing nothing, waiting for that to finish. Worse, if you end up with a situation where there ends up being kind of a circular dependency or a callback of some kind, you can run into deadlocks. This is a common thing that I see happen with a lot of people who do .wait and .result is they go, we've got a lot of threads spinning up. Things are really slow. Yeah, don't do this. Bad. Async and await all the way down. Right? Async, once you start adding it to your code base, it's like a virus. It permutates up and down in all directions. Right? You add it to a base level method, make that async, that propagates up. Just like when we made increment async and we did it as a task, I did it quickly, but I had to come in here and change my increment count up to an async task. This ends up being the top level method in my case because this is the command handler. But in general, it's just going to keep propagating up. So you can imagine 4, 5, 6, 7 levels deep. That asynchronous thing is going to just keep propagating. And it annoys people, and you should do it because it's worth it. The moment you need an asynchronous thingy, make your code asynchronous. That is the way to do it. Now, if in the very rare situations you have an asynchronous thingy and you must absolutely force it to run synchronous, I will refer you to Stephen Taub's blog posts. There is an option available to you that involves task.run and .wait and .result. I am not going to show it because it is bad and people should never use it. Should rarely use it. But in the rare case where you actually need it, because, maybe you're interfacing with a third party or whatnot, and you don't have control of something, and it has to work that way, fine. If you have to do it, go read that blog post. Actually, tell you what, I'll do one better. Stephen Taub. Yeah. Believe it's this one. Let me just double check. Yeah. Now, I'm gonna just draw your attention to one little thing here. The size of my thumb on the scroll bar. This is put forward as a blog post. This is not a blog post. This is a short novel. Okay? At the end of this, you will be very, very familiar with how async and await works. But this is absolutely amazing. So for anybody who wants it. And then let's see. Sync over async is his other one. This guy here. Yeah. So there's this one and its corollary post, which apparently is, I don't know why his link is dead inside the blog post, but those ones there. If you would like to take a look at this before you do something crazy, right? Before you start doing the task.run craziness, please read them. It is worthwhile. Okay, now, real solutions. Things that won't get you laughed at in a code review. Okay, so a couple options available to you. And there is going to be no silver bullets here. Everything here I'm going to couch with, it's going to depend on what you're doing and what makes sense at your implementation. So, option one. You could, in theory, just do this. Let's see. Counter service. What? Oh, I didn't add it to the interface. Hang on. Do that real quick. So, Init Async. Right? This is a thing that can be done. Right? So if we launch this and we click, you'll note I'm going to end up sitting here for about a minute. I should have probably set the delay to be a lot less for this demonstration. So I'm going to talk for a minute to stall for time. If you are able, one possible option is to simply just call the initialization code at appropriate points in your code. So for example, I was working in a project. We have various things that have something very similar to the dialog host in the material design project. And before a dialog is shown, it's very common for the dialog to want to load some sort of data, specifically asynchronous, database, web service, whatever. And so what I had done is I had created a base class for all of the dialogues, a dialog view model as it were. And I put an Init Async method right on that view model. And because all of our code for showing dialogues was flowing through a common code path, it was very simple for me to say, okay, here's what we're going to do. We are going to go through, and before the dialogue is shown, I will actually call that Init Async for you, and then we'll go through and show it. That if you have a code path, like this looks stupid, right? Saying, well, we'll just make the caller call Init Async at the right point. It looks stupid. But depending on your structure and what you have set up, there may be a reasonable point where you can, where even though, it's like, I really want it in the constructor. No, you don't. You want it somewhere else. Trust me, you want it in something that's asynchronous. And it's possible to move it closer to the call site and say, oh, okay, here's what we'll do. We'll just do it at time of the call site and put it through. Now, another option available is to say, okay, rather than doing it there, because you'll note this thing's now going to reinitialize every time I click this button. That's real annoying, right? That is probably not what you want, right? We could come in here. Let's actually clean this up. Let's do something like private bool. You should spell bool correctly. Is initialized. Thank you. Okay, Copilot, write the code for me. Thank you. Thank you. See, Copilot's such a good helper. Okay, so we could do something like this, and now we don't pay the cost every time, right? And we're gonna dial this sucker down from seconds 10, because I can stall for 10 seconds either than a whole minute. 10 seconds is about how long you need for a drink of Mountain Dew. Okay, so I click it. We take the hit. That's okay. It's okay. We can get over it. We think for a moment. We stall with talking. We say something useful. Great. It initialized. We're now at 3 clicks. right? We can click again, immediate, because we're already initialized, 4 clicks, 5 clicks, great. Reset, we're still not passing the data through, so we're at 6, whatever. That's fine. This is a possibility. The other thing that's a possibility is something like Init Async. Move your initialization inside, make your method async, because oftentimes trying to do something asynchronous at the constructor is difficult, especially if you aren't directly invoking your constructor, which with a DI container, odds are your constructor has 0 references. It's just not something you called directly because you said, well, I never called counter service. I always just used counter service. The constructor is this magical thing that just shows up for me. Great, fine. Making the methods act on the interface async, and then you don't even need this. Right? We can get away with this, and we can come down here and go, oh, okay. Rather than doing it in the constructor, because the constructor shouldn't be doing this logic anyway. The constructor for a type is designed to construct the object into a valid state. And some people go, well, until I've read this starting value, it's not in a valid state. It's not? Really? It seems like it's in a very stable state to me. Even though count hasn't been initialized, there's no way to call increment without initialize being done, and this is now all encapsulated inside of my type. So this ends up working rather well. Okay, real quick, task clear async. We're going to do this because this is bothering me that we aren't properly handling this, and we're just going to keep going. Let's see. Await file. Write all text async. We're going to write empty string. No, we are going to write to count.txt. That file name should really be a constant or something. And we're just going to do an empty string and call it a day. There. And we're just going to come down here. Async task. That is not how you type async task. Let's try that again. And then we're going to go with counter service clear async. And we should probably await that so that I don't look as dumb as I feel. Okay. So now at least when we clear it and click the button, we aren't going to get those weird increment things. Just going to test real quick to make sure. Click. Thinking while it initializes. Stalling for time taken to do. Boom. Okay, if I reset and then click reset. Oh, reset isn't actually, so it turns out you should probably do that. Otherwise, reset isn't going to do a darn thing. We wrote the data to the file and then proceeded to not change our internal state. This is why you write unit tests. Because unit tests wouldn't have been that stupid. Or maybe they would have been. Okay, if we reset now, there we go. Now we're at least behaving like a real boy. Okay, great. Huzzah. Okay, so options. 1, create an initialize async method and either invoke it at the call site or at relevant starting points, or move it inside of your class and invoke it from the various members that might need to initialize it. So for example, this guy here might also need await init async. Right? Obviously that's kind of stupid, but it would make sense that all members in here might need to verify initialization has been done. Right? Simple, straightforward. That's all it's going to take. Okay, other options available to us. Another one that we can theoretically leverage is we could leverage hosted service. Okay, so hosted service is once again something that you are going to be picking up by leveraging generic host stuff. And this guy here is coming from the Microsoft Extensions hosting. So if you do not see it, if you don't see iHosted service showing up, confirm that you have Microsoft.extensions.hosting enabled. Okay. The idea with a hosted service is it is something that you want your DI container to spin up for you as part of the lifetime of the host, right? So we're using the generic host. A hosted service is a service to serve the host. So when you have a hosted service, when the host starts up, it will call start async on your hosted service. When the host shuts down, such as when you're closing down your app, it will call stop async, right? So return. For now, we're going to redo return task, complete a task, right? Bippity boppity booyah. The advantage of this is you could theoretically do await init async. And because this is an asynchronous method, it gives you a nice, easy way to go through and do this. Right? So I'm gonna comment this out for the moment. I'm gonna comment this out, and I'm gonna comment this out. And then in order to actually have this work, you can't just add the interface, you actually also have to register it. So if we come over here and we go services.add hosted service, we can do counter service. Now, this doesn't work. Okay? This doesn't work. Let me demonstrate why. So we're going to do a breakpoint in start async. We're going to do a breakpoint at the end of start async, and we're going to do a breakpoint in an increment async. And so we'll catch it. We'll catch it in those three places. Okay, so our app is starting up. We immediately hit our breakpoint at start async. Great. We hit the go button. We're waiting. We're waiting. We're waiting for initialization. Okay, we finally finish. My window isn't up yet, just to be clear, right? We've added to our startup time. So we go there. Now we have this. Now we have a hosted service. Now I click the button. My count is 0, right? So I go through. I write async. Great. Do this. Write async. Right? This seems like it's working. I'm going to close the app. I'm going to launch it again. We catch start async. I'm going to let it go. We're going to question why my cup is empty. And grab another Mountain Dew while we're waiting. Great. That was 10 seconds. We've finished initialization. Great. We're going to come over here. We're going to click the button. Our count is 0. Okay? It's not working. You might go, hang on, something's off here, right? I just saw start async get called. It called init async. What's going on here? Well, let's examine. Let's restart one more time. So we know our file has a 2 in it, by the way. Okay, so we get into start async, and I would like to go to let's do my locals window. Okay, so I have a test counter service. I'm going to right click on this and hit make object ID. So you'll note, I don't know if people have seen this in Visual Studio. When you hit make object ID, it gives you an ID by which you can reference this object in the watch window, immediates, whatever, right? You now have basically this nice little static identifier that you can use to go and get at this instance of counter service. It's also really handy because you can use it to compare if two things are the same instance. Spoiler. We'll let that thing go for a moment. Take the opportunity for a do. Question why I haven't made my task.delay shorter than 10 seconds. Okay, so we finish our start async. Our window launches, we're good. We click our button. We get in here. Let's go to our locals. And the first thing I'm going to note is that this test counter service doesn't have the $1 next to it. It's not the object. It's not the same instance. If we hit make object ID, we'll note now, oh, we've got both a $1 and a $2. And if we look at these guys, we can see $1 has had its count properly initialized to 2, but $2 has not been initialized. You'll note is initialized false. Oh, something's wrong here, right? So when you do add hosted service, let's take a look at what this guy does. It goes through and it does a try add enumerable, meaning it's going to attempt to add multiple iHosted services. This iHosted service thing is expected to have more than one thing, hence the enumerable, right? You can think of it as a list with this as the key. And you can see it creates a service descriptor of a singleton of iHosted service. Hey, Andrew. I hope it's a fun topic. A couple of my colleagues inspired it, so they unfortunately get to be milked for content now, and they shall remain nameless unless they're on, in which case then I call them out by name. Crap, I've forgotten what their Twitch handles are. This is where you see people closing the windows. So add hosted service is going through and trying to register it here. Now, this is problematic, right? Because we are no longer in control of this service descriptor that it's creating. Because remember when we talked earlier about a service descriptor, the service descriptor has a few things on it. A service type or a key type, right? Think of this as your interface type in most cases, right? A lifetime, and then one of these three implementation-y things tacked on, right? In this particular case, it's going to be implementation type that gets specified because it's using the generic method here, right? This generic method says, build me up one of these things that's of T service, T implementation, and the given lifetime, right? Nothing fancy here. So we've got service type, implementation type specified, lifetime of singleton, but that means that you've got two service descriptors now registered inside of our DI container. Because remember, iService collection is not fancy. List of service descriptors. That's it. No fancier than that. Ish. Small asterisk, I'm only mildly lying. It's functionally as a list, you'll be fine. So we've added two instances of counter service, both keyed slightly differently. Now the workaround here, right? And the workaround here is very similar to what we did down here, right? So here we registered up a singleton of weak reference messenger, and then we did an add singleton where we reach back into the service provider and grab that weak reference messenger out and register it with another service descriptor keyed on iMessenger. Right? So these two each add a service descriptor. This service descriptor has the service type and the implementation type specified of weak reference manager. This one, this add singleton adds a service descriptor with a service type of iMessenger and an implementation factory that returns a weak reference messenger. And that factory method recursively calls back into our DI container and says, hey, by the way, DI container, yeah, give me that weak reference messenger that I registered already. And so this one ends up resolving to this service descriptor, pulls that instance back out. So now it doesn't matter if what is requested is a weak reference messenger or an iMessenger. Both are going to get the same exact instance. We need to do the same thing here, right? So we want to go here and go provider, and then you should spell correctly because that's important. Get required service, and then we will do counter service. And actually, this doesn't quite work either, because we haven't registered anything with a service type of counter service. So let's do you know what? I'm comfortable doing this. So we can either do yet one more registration and recursively call each of them. But because we implemented iHosted service on counter service directly rather than on the interface, you can't have the factory return something that doesn't implement iHosted service. But in this case, because the implementations are right next to each other, we're just going to hardcast because we know how that's going to resolve. We could do this same pattern again and forward this one into that and this one into that and blah, 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 blah. Yeah. Okay. Fire this guy up. Hang on. In the interest of me not being annoyed, we're going to just turn that down from a 10 to a 3. Okay. So we start, wait 3 seconds. 1, 2, 3. Boom. We hit our second breakpoint. Great. We come over here. We hit click me. And you'll note now count is 2 and is initialized is true. We've gotten the same instance in both cases. I should have probably done the make object ID thing again just to prove my point. So we'll go locals, make object ID. So there's our $1. We've got our first reference. Come back over here. We'll click. And now when we look at our locals, we'll note that this has the same $1 as our other one. So the same instance that we got for start async is now the same instance that we are calling increment async on. So now everything goes back to working just fine. So benefits and drawbacks of this approach. This works well if you are okay with your generic host managing the startup of it. And you can do whatever you want inside of this start async. The documentation for iHosted service will even show you how to go through and actually, maybe I'll just pull it up. There is create a timer service. So in the event that you don't want it to just do one instance of initialize, like for example, you want a recursive thing that's just doing do work, right? You can, and I will share a link. You can go through and register up a timer in your start async, for example, and have it start incrementing. And so you can have your hosted service doing work in the background, right? And being able to go through and build it up. There is also a background service class. So in the event that you really do want that background processing, there is a very helpful base class you can derive from background service. And then all you have to implement is execute async. And then once again, there's a cancellation token, all that stuff. It deals with everything for you. You just focus on this and the background stuff just works. Great, huzzah. Let's see, question from Justin Bieber. Who calls start async? 0 references. Very good eye, very good eye. So start async in here. So one, it's coming in from iHosted service. And because we are using the generic host, the host is what calls it. So hosted services are started by the host and stopped by the host. So start async calls when the host starts, stop async calls when the host is shut down. So, and I realize there's actually a bit of a bug here. I am never actually stopping the host. I mean, I kind of am in the fact that this using is going to trigger as soon as we exit main or on our way out of main. So it might not be as big of a deal. I'm curious now. Hang on. I want to see if stop async actually gets a chance to be called. I have a sinking suspicion that stop async may not get invoked. Let's look. And that would be an artifact of my template and how it spins up the generic host. So I shut down. Yeah. Interesting. I'll have to fix that. Because we're starting the host here, but we're never actually stopping it. And it should probably, there should probably be a registration here for app shutdown. Or what is it? On shutdown, shutting down. There's an event here for this. Exit that. So there should probably be something akin to this here where it ends up grabbing it and shutting it down. But then you also have the async nature to deal with. So details, we'll handle that. That's probably something I will put in my template once I get it in. But yes, so hosted services are an option available to you. And again, the whole point here is you have some sort of initialization. We don't want to do, again, this bad. Please don't do this. Bad. And again, there's the wait and the result, and all of those are bad options. And there's the trick with task.run. But please don't do that until after you've read Stephen Taub's blog posts. Okay, that's just the rule. If you're going to use that, you have to read his blog post first. If you make it through the blog post, the short novel, then you are allowed to use it. That is roughly the rule I would give people. Must read first, then you may do. So, but hosted services do give you a potential option if what you need to do is kind of one-time level initialization or background initialization, and you aren't as picky about when that gets invoked, it can be an option for you, right? Again, weigh that against doing the invocation at the call site, because those are kind of functionally the choices available to you. Let me make sure I'm not missing anything. Yes. Okay. So last option, and I kind of spoiled it earlier with the logger stuff, but that was kind of the point in showing the logger stuff. See, method to the madness. I actually kind of like mentally thought through the order I wanted to show things tonight. It's weird bit of planning I did. I'm not used to this. Normally I just wing it. Okay. So the other option, and it kind of goes back to where we were before. So I'm going to leave the hosted service in for reference for people, but I'm going to do this so that I don't have to. So this is just as reference, right? Again, I don't think the iHosted service trick is good as a general pattern. However, there are use cases where it is the best option. So it's worth being a tool in your tool belt, but it's going to be one of those tools that you don't reach for. This isn't the hammer, right? This is going to be something a little more specialized, not your generic all-purpose. Okay, so the other option here is don't use the constructor, right? And it's like, well, we aren't using the constructor. We have 0 references. The option, or I should say the last option, kind of goes back to how ILogger is set up and registered, right? So what we could do is we could do public public interface I counter service factory. And in the past, I've shown people how to do clever tricks with the factory where we register up a delegate. I don't have any of them in here before. I've shown people doing factory methods with just straight delegates. If you're doing it to do this async stuff, I would not use a delegate for it. You can make it work, not recommended. Okay, so, but what we could do here is create, how about just create async? Okay, so we could do this, and we could do public class counter service factory. Counter service factory, and then we can go through and implement create async. And now here you'll note something. This is very important. We have a create async method. That sounds remarkably like something that could invoke a constructor and then could await an init method. Yes. Hey, see, doing great. Having fun with DI and async stuff and C#, which just means I'm in my happy place. And I have a Mountain Dew, which makes it even better. Okay, so the naive implementation here looks something like this. Var rv gets new counter service, right? And then we do await rv dot init async, and then we do return rv. Right? This is good-ish, not great, but good-ish. And actually, this is, yeah, a factory method that's called create should probably return counter service. Should probably actually return the thing that it's creating. That sounds like reasonable expectation, right? But you'll note now we've set ourselves up with something that can actually do the creation and ensure that init is called and finishes before the instance is handed back. Effectively, we have given ourselves sort of the rough equivalent of an async constructor. Ish, right? It's not perfect, but it's close. Right? And then we come in here and we do services, add singleton. It could, because in general, you're going to be adding factory methods as singleton. If they aren't singleton, be cautious. That usually is that's a code smell that I look closer at. Not saying it's bad. And then, for example, down in here in our main window, rather than doing all of this stuff and taking in a counter service directly, we could take in a counter service factory, right? Factory. And then down here, we can do counter service factory. Let's see. I got to actually type private I. Why is that? Oh, those are declared public. Autocode for the fail. Let's see. You have to be able to spell counter service factory for this to work, and be able to type. It's a very complicated operation. All right, so we take this, specify this. We question why we made all of these public, and we make these things all private because they aren't being exposed. Let's not expose them unless they're needed. There we go. Okay. Okay, so we've got a counter service factory, and now we get rid of counter service. For example, this guy goes bye-bye. And now what we can do is we can go counter service. Let's make this guy, actually, let's do this. Let's just make you nullable and give you a setter. Right? Let's see. Var counter service gets counter service, ding ding boom. Let's see, counter service factory dot create async. We do await, and you question your sanity. I guess that works. And then this guy becomes counter service. Let's see, what are you squawking about? Count. Semicolon expected. Okay, fine. I should learn how to type semicolons. Okay, so 1, verify functionality, and then recap. So we come in here. I'm just going to breakpoint so we can step through and watch this thing work. Okay, so we come in here. Counter service is initially null. All right, so we're going to end up invoking our factory. Our factory is going to create a new counter service, going to call initialize. We're going to wait for a moment. We're going to get back an instance. Great. It's now been initialized. We now go ahead and call increment async. We do the incrementation, write the file. We go away. Everyone's happy. Right? And then we will continue. And then here we click the button one more time. Counter service in this case is already set. So we just set the local. We don't actually go and reach across the factory. That's what this null check is here for. We then increment async. Great. Do all of the work. Set the count, and we're off to the races. Let's see. What is the point of 147? Why do you need the var? Great question. Great question. So it would be perfectly valid to go through and just do this. This works. The thing that I don't like about it is when you do it like this, what you are setting up is you're making the assumption that this property doesn't change out from under you. So the 147 will check the property, it'll invoke the property's getter, check the value for null. If it is null, it'll await this asynchronous method, set the new value called the setter on the property, and then down here, it's going to re-invoke the getter of the property. And so it's making an assumption that nothing nulls out that property between 147 and 148. Right? If instead we do a local field, local values inside of a function are thread safe by definition. And so anytime you start using async and await, my brain immediately tries to think about thread safety because it can be somewhat problematic. Now, in this particular case, relay command doesn't allow concurrent executions, and we don't really have another path in that's going to end up nulling this out on us. So functionally, it's not really possible. However, in general, I will oftentimes, if I'm going to access a property or a factory method, I will cache that value in a local variable, just because local variables cannot change on me between two lines of code inside of a method. So you get thread safety without needing to do locking or any of that, just by virtue of access the properties once and then never again. Right? Which is, so this counter service, I can guarantee is now not null on me, assuming that my create async always returns a non-null value, of course. And I don't have to worry about if somebody nulls out that property, it doesn't affect this execution of the method because the local value is already got that previous instance and it's not going to change out from under it. So it's one of the clever tricks of I will oftentimes bring things into local values, and it's not obvious to a lot of people that I'm doing that for thread safety. It just works. So it's one of those things that it's real subtle. And it was a trick that I learned a long time ago from one of my mentors. And when he told me that, I'm trying to remember how he phrased it. It was kind of very blunt of local variables are thread safe by definition. And I went, what? And it took me a minute of processing that statement. I'm like, local variables are thread safe by definition. And I just kind of had to think through, like, my brain was not moving real quick that day. And it took me a little while to get through it. I'm like, oh, and then there was the light bulb moment. And yeah. So it's also the reason why you'll see people pattern match into a local variable with a null check, because that local variable can't change on you. So it's great. Obviously, our clear count is broken because of all of this stuff that we've done here. It would effectively need the same type of treatment. And it's really tempting. It's really tempting to say, well, hang on. I've got this factory and I've got this property. What would be really great is if I didn't have to have this get set thing. And what would be really great is if I could just, inside of this getter, just go, hey, why don't I just do, counter service factory dot create async, right? This is the other place, similar to constructors, where the asynchronous messes with people. You can't. And the reason is because properties already have a well-defined signature. Your get method is a singular method that returns the property type and takes no parameters, right? That's it. The set method is a void method that takes a single parameter that is of type of the property. That's it. Get set are nothing fancier than just two well-defined method signatures. And so you can't make them async. Therefore, this would something like this inside of a property would never work. Right? So it's really tempting to want to do it. Resist temptation. Back away. Again, it's just like with constructors. If you find yourself needing to have a property do something asynchronous, I question why it's a property and not a method. Because if you need to do asynchronous stuff, properties are expected to be to not have significantly longer execution times than accessing a field, right? They're expected to do some validation, some minor logic, and then return back. They are not expected to do long-running asynchronous things because properties are expected to be quick access. Methods are expected to do more. And because a property is just a facade over some common method types, that is one option of doing it. So this gets us all the way into here. And this is, I think, closer to a general purpose pattern. And again, I'll preface it again with all of this asynchronous stuff. There are no silver bullets. Everything, the answer on all of this is it depends on what you're doing. But this kind of factory pattern is much nicer. Now, you will note here there's kind of an issue here. Is this guy is now tightly coupled to this constructor. And in an ideal situation, what we would really like is for him to not need to know anything about this constructor, right? What we would ideally like, let's put the init async back, right? We would really love it if this factory could do something special for us, right? Like not needing to call this constructor would go a long way. But because our factory is DI injected, now we can have some fun, right? So this is the case where we could potentially leverage something like this. Create counter service, right? And again, I'm going to leverage a func here for this, but you can go any number of ways. And calling the constructor directly from inside of a factory method is okay. Just to be clear, that is an option. Factory method's purpose in life is to build things. That's its purpose. And if building things means calling a constructor, that's okay. But you could imagine as soon as we go through and do, for example, like an ILogger, say all of a sudden counter service wants an ILogger, right? Now it's like, oh crap. Now this thing needs to take in an ILogger, right, of counter service logger, and we gotta cache this guy off, create an assigned property, right? All so that we can just pass it here, right? So if your factory method is directly invoking the constructor, there is coupling there. Constructor methods are static methods. So it's worth kind of considering. Let me circle back to that in just a moment. But if we go with kind of this func approach here, what we can end up getting away with. So I'm going to switch the order of this real quick. RV gets create counter service. Once again, spelling is important. And so all we're doing with this func is hiding is decoupling ourselves from the constructor call. That's it. But now what we can do is we can do services add singleton, and then we can register func of counter service, right? And then inside of here, we're going to do that same provider trick. And then we're going to do provider get required service. That's the factory, but that's close. Let's see. What? Oh, because it's not of the right type. Okay, so we go there, and then we are going to do, we're going to make this the interface, and I'm going to move these guys down here next to the other ones, just so it's a little more clear what we've got set up here. Right, so we got a little clear. So counter service is still registered here. This is func. The func reaches back. So provider lambda paren lambda is creating a delegate of type func that returns an I counter service. And then if we go into our factory, we're going to do I counter service factory here. And then this guy only needs to act on the interface. He doesn't need to know anything else. And then he can still call init async. And again, the big advantage here is as this constructor changes, again, maybe you add a logger or something to it, the factory is now ignorant of that constructor change, and the factory can focus on what's important. Create an instance, make sure it's initialized, then return it. Right? Do whatever needs to be done here. This might be more than one line. Away you go, right? If you need to do like interface segregation, sometimes having an async on this service is probably not appropriate. You could theoretically have a slightly different interface, but then if you change that, going back and forth, if you do interface segregation inside of your DI container, you need to make sure that you've done appropriate registrations that all have the appropriate service type for those different interfaces. Right? In our case, we're trying to keep it a little simple and not sprawl too much because it goes out of town. Let's see. So what do you think of object-oriented programming? What do you think of functional, written more imperative, and a bit into math and studying more functional programming? So in general, like my personal bias is definitely object-oriented. That's a fairly big personal bias just because of the type of C# work that I do. Both have their place. I think with all software, the big question to answer is what problem are you solving? So in an ideal situation, and this never happens in real life, someone comes to you and says, we need a piece of software that solves X problem. Please create it, right? Or we need a piece of software that does X. Please create it. That'd be great. Rarely are requirements clear cut, and oftentimes rather than that statement being the start of work, it is the start of a discussion where we figure out work. And that's oftentimes where I spend a decent amount of my time, is just figuring out what people want. And so depending on what you're building, I think there's oftentimes a good case to be made for which kind of pattern makes sense. If you are in a lot of cases modeling particular domains, object-oriented makes a lot of sense. Our world is filled with objects and nouns and things. And oftentimes object-oriented paradigms lend themselves well if you're trying to model something that has lots of nouns and things. Functional lends itself really well when the problem that you're solving is very procedural. And so you can, I think my answer is I'm biased towards object-oriented, but that is based upon the type of work and the language of choice that I tend to do most of. But I think your selection really should come down to depending on what is the problem that you're solving, because that's what all software is solving problems. Developing a database-driven website. Okay, so like, I guess it depends on what the contents of the website are. My opinion is that sounds like something that's probably a lot more object-oriented, because I imagine as you start building out your website, most websites have a set of things that they're doing. I started building out one for managing the backlog of requests, effectively a really fancy to-do app, or a to-do list app, which everybody builds at some point. But at the end of the day, the problem domain was such that it was modeling the objects, of being able to build it out. And so that works well. MySQL MariaDB database, yeah, you should be fine. Some people get very hung up on the particular technologies that they pick. In general, if you pick anything mainstream, you're probably not that bad. Like, I don't know if there's anything mainstream that I would say is horrible. Because kind of by definition, if it made it mainstream, it means it had to be good at least one thing. Nothing makes it mainstream if it sucks. Databases about media with a focus on movies. Oh yeah. And PHP. I actually used to do a bunch of PHP work a while back. But especially with like MySQL, you'll find plenty of tutorials and documentation about getting all of that set up. PHP is incredibly nice because it is there's not a lot of magic that goes on. Unless you pull in like one of the frameworks that adds some of the niceties to it. PHP is really you get what you see. It's very straightforward, and so I've seen a lot of people teach with it because there's nothing complicated to explain. It's like you wrote this line of code, it does this. Okay, next line, and you go through it. So it's very popular for that, and a lot of people like it because there's no extra stuff that kind of sneaks in or extra things that it's doing for you. You can get some really great performance because it does nothing extra. The drawback is it does nothing extra. So there's always this weird trade-off between a lot of things, and JavaScript frameworks are very guilty of this. They always want to, like, the moment you have frameworks that do stuff for you, they implicitly bring in the author's opinions of how things should be built and how things should be structured, and that's fine, right? That's the point. You can't have a generic framework. Everything has some level of opinion. Even the .NET generic host has opinions about how things should be set up. And so because of that, you end up in this situation where if you bring in the framework, you get the niceties of it, but you then also have to learn the framework and the magic and how it's doing things. Have you ever had a case of using something mainstream to later find out something is horribly wrong, like Log4j? So, trying to think of the worst case one that's ever bitten me. So the Log4j vulnerabilities that I assume are being referenced here didn't really bite the .NET community very much. There was only like a handful of cases that I saw where there was like some weird interop thing because the .NET port didn't have the same vulnerability as the Java one. I'm trying to remember the Java feature that got exploited. It was basically their equivalent of reflection, which was kind of fun to read the analysis of it. I don't know if I've said that it's horribly wrong. There are, I think one of the worst offenders was like a Xamarin or Xamarin Forms. And it's not necessarily that something's horribly wrong. It's that things changed or didn't work the way that I wanted or expected. Like the early versions of Xamarin Forms were a miserable nightmare because you lacked a lot of the tools needed to customize it the way you wanted. So if you wanted the off-the-shelf experience, it was great. As soon as you wanted to customize it, it became a miserable nightmare. And you had to dive into custom renderers and all that stuff. And in a large case, they've mostly fixed all of these problems with Maui. Now, Maui's not quite a bed of roses. There's plenty of things that are problematic or don't quite work right. And like, I can't fault that team much because they're trying to do something incredibly difficult of I write C# and have it work on all these different platforms and these different tool chains. And how do I make all of those work together? And it's like their tool chain is insanely complicated, and how well it does work, I think, is amazing and awesome. And I think it is a very worthwhile platform to build on. But there are rough edges in places that just feel rough. And I don't know how easily they'll ever get smoothed out. I don't know if I've ever been bit by a major vulnerability. I'm trying to think if there's been one. The places where we do like vulnerability scanning, Like we've done a bunch of work with like FFmpeg, and oftentimes once you get down to having a lot of native libraries, that's where things can start to get interesting. Like FFmpeg has a pretty big dependency tree of all of the stuff that it relies on, and there's a lot there. So a vulnerability in one of those just spirals, because then in order to get that thing, you need that dependency patched, and then this dependency patch needs to roll up and roll up and roll up, and so it can kind of be a pain. But it's never really been, I don't think I've ever been directly bitten by the vulnerability itself. Oftentimes, because we do vulnerability scanning, it's usually the vulnerability scanner that catches it as soon as it comes out, and then we start fixing it, right? And so I don't know if I've ever been hit by something because it was like an active exploit or anything. But yeah, definitely the using things that were mainstream and then they didn't work as well as I had hoped. That I think I can say for certain. I've been moving some code to arrays and for loops. Great. Depending on what it is, that can be a very useful method. It's unfortunate that, so there's a running joke that to become a software architect, you have to learn the very important phrase, it depends. And I say that a little tongue in cheek, but it is accurate. There's so much in software where people would really like to be told this is the right way to do things, and there's not a great way of doing that. Even with some of this stuff that I was showing tonight, is there's not a one way to do it. And a lot of it does depend on the structure of the code that you're writing. Oh yeah, what about a case like Unity 3D that has an awesome product for years and then they go and do something which makes you have to swap to using different software? Oh yes. Let me tell you a small story about that. Just hypothetically. Hypothetically speaking, and this will be all hypothetical for a moment, if you missed the mock controversy that came up, what was it? 2 months ago? Similar. There was a lot of blog posts written on it, so I won't rehash too much of it. The short version is there was a change that was put into the mock library that a lot of people very much hated because it had some very sus behavior that many blog authors liken to virus or malware, right? As one of the project owners of the AutoMock library built on top of it, I have a small vested interest in it not sucking and dying. Just a small one. Because it is my preferred mocking library. But it is worth noting, it's basically run by two guys. Like, that's it. There's not a lot of people working on it. And it's kind of a big time sink. So one, if you are able, supporting the packages you depend on matter, but he put in a change and for like a week or two, people flipped out because they were panicking. And me, I did a stream on it shortly after the change went in, and my answer to everybody was stop panicking. Like, just don't update the NuGet package. Pin yourself at the old version and the problem goes away. And so, yeah, having things where it definitely gets yanked out from under you and you panic. I think the key thing in a lot of cases is unless something happens, like Unity was a little different because of the licensing change, but in a lot of cases, if it's a code change, even if the code change happens abruptly, oftentimes there's some lag time before it actually is a problem for you, right? Like people freaked out when Microsoft bought Xamarin. They're like, oh no, it's going to die and we need to all update away from it, and panic mode. It's like, calm down and relax. One, nothing's forcing you to update right this second. So stop freaking out. You have time to figure out a plan. Don't knee-jerk reaction. Like, that's the biggest thing, is there's too much knee-jerk reactions that happen, and people flip out and go, I'm going to migrate my entire project away from insert thing here that has annoyed me this week. It's like, or hypothetically, we don't do that. We wait and see what options come. Like with the mock thing, there's now a version of the library that is completely open source, and the other stuff has been stripped out. 4.20.69 also has the stuff stripped out. So should you switch over to that other library? I don't know. There's nothing forcing me into not using this version right now. So waiting will oftentimes, the versioning is also sus. Like, just like we're going to just look at the published versions. I think the problematic version was 4.19, or I don't remember what it was. It's now been unlisted, so it no longer shows up in the query. So there's that. But yeah, so I think what I would say is, in the event that something like that happens, step one, don't panic, because that doesn't do you any good. Step two, don't make any rash decisions. The first thing to do is evaluate how and when, key part, when do you need to ingest that problematic dependencies change, right? Regardless what it is, a licensing change, code change, whatever. If there's nothing pushing you to do it, don't. Like, there's usually nothing lost by waiting. And then once you know when your drop dead date is for when you would need to ingest the change because of whatever's happening, then you go through and say, okay, as we get close to that, let's start evaluating what options are available and figure out the migration path there. Have you used F# or Q# before? I have done a very small amount of F#. I was learning it a little bit because I was helping somebody out with ironically, a C# source generator. They were building in F#. Don't ask. So I was doing that. And I did Java a lot in university. Once I got out, my first job, because I had in university, I'd done VB.NET and Java. They told me, they're like, oh, C# is just smashing those two things together. And I went, oh, okay. And then I fell in love in C#. To be able to go through and do it. Let's see. This can be somewhat mitigated by having your own abstraction on top of third-party stuff. You swap out if you do different library if needed. Takes more effort up front, but may pay dividends later. No, probably not applicable to Unity though. Yeah, there is a balancing act there too, because some people will put a lot of abstraction in, and rarely does it get leveraged for anything. So I will generally, I guess it depends on the library. There's certain libraries that if they don't play nice with the Microsoft abstractions libraries, I will probably put my own abstraction on top of them, just to kind of, put lipstick on a pig and make it work a little better. If it is something that's kind of a more mainstreamy library, I'm probably not going to, especially if it's one from like Microsoft. So it varies a little bit on what I'm going to put an abstraction over. But certain things that you think if you have reason to believe you might swap it out later for something different, yeah, throw an abstraction on top of it. If you don't have a reason to believe that you might swap it later, don't, right? I wouldn't necessarily build an abstraction for something that you don't think you have a reason to swap out. Like a good example of that is like Newtonsoft.json. Like, I forget, 12 years, something like that. Newtonsoft was the #1 NuGet package, and it wasn't even close. Like, Newtonsoft ruled the world in NuGet download numbers. There was no question about it. And a big part of that was ASP.NET for a while took a direct dependency on it. So everyone who spun a new ASP.NET project got Newtonsoft.json. That boosted the numbers a lot. But then a few years later, come along, now we have system.text.json. And so before, people would build things that were arguably tightly coupled to Newtonsoft, and there wasn't a big question on that because, okay, like you could use the component model annotations and whatnot to try to not couple yourself to it, but that only loosely decouples you because whatever you migrate to, that's only an advantage if the thing that you migrate to also supports those annotations. It's like, maybe it's okay, maybe it's not. Like, because that's the problem, is you can build an abstraction, but sometimes those abstractions start to get real leaky real fast. And building out a perfect abstraction is oftentimes not cost efficient unless you have a reason to believe you need it. So there's that balancing act there. But with system.text.json, it's like, oh, well, maybe I should put my JSON serialization behind an interface. Yeah, help that Jason got hired by Microsoft to work on Azure stuff. Yes, absolutely. And as I understand it, he also helped with system.text.json, which was perfect. But so there's the question of, well, shoot, should I put an abstraction there? And I don't know if there's a clear-cut answer. I'm dealing with a project now that there's a lot of stuff that's tightly coupled to Newtonsoft, and we're like, well, shoot, should we switch over to system.text.json? It's like there's some advantages there. It's faster, but it has less features. Is that worth it? At the end of the day, it's a bit of a judgment call. Does it matter? Like, do you care about that perf? Maybe not. So it varies a little bit. But yeah, great questions. Like it is an interesting thing to go through of when do you put in the abstraction? Like I said, I think the answer is it depends, which is just great. In terms of like a WPF application, I generally will put in some level of abstraction because you've got your view model, and then there's usually some sort of like business layer that comes in there, and you can kind of start to tease things out a little bit. Because if you put all of your business logic straight in the view model, like that works for a small application, but it doesn't scale well. So there is I should say this. I got bit at one point many years ago because I had put too much logic too close to the view models. And then there was a desire to say, oh, by the way, we're no longer going to run it in a WPF application. We want this same logic, but we want to go run it in this cool new thing called .NET Core and run it cross-platform. And I went, crap, because it meant having to go through and do a lot of refactoring to kind of break those things apart. So having that idea up front of what things should rev together and what things should stay together is, I think, a skill that is best taught by the School of Hard Knocks. Okay, one other thing. If you haven't seen this is something everyone should read. You'll note this is an amazing paper written June 26, 1999. Some of you may not have even been alive when this was written. And this is very applicable today. There is a lot of things here. Some of the big ones, the idea of like the piecemeal growth, keep it working, and shearing layers. These things here are excellent, absolutely excellent of being able to kind of think through this. But definitely recommend this to anyone who is at all responsible for making design decisions in your code base, right? Some people are literal code monkeys who I was given bug to fix, I fix bug, I move on, right? Great. Not a lot of thinking involved in that. But as you start kind of moving up into kind of more senior and architect level things, those types of decisions start to come onto you more and more. Keeping these principles in mind will take you far. So definitely worth reading. Okay, cool. Okay, well, I think I'm going to wrap it up for tonight since I've got a bunch of stuff to do. Oh, hang on. Another interesting question. What do you think of the new coding style in the newest C# where classes are what I would call headless? Confused the hell out of me. Yeah, so the syntax is not that different in my head from the record types, but the record types are also fairly new. So if you haven't seen those, it's kind of similar there, because I think you're talking about the new primary constructor feature. Here, we'll pull that up. Hang on. And pooja! There we go. C#12. I think this is the features. This guy here. Yeah, where you get something. Let's see, initialize property, create a mutable struct. Why are they all doing structs? Yeah, so you get something here that's very akin to record types, in my mind. The really interesting part about this, if you play around with the feature at all, these things are the exact inverse of a read-only field. So a read-only field is only assignable inside of a constructor. These things are only assignable outside of a constructor, which I nearly died laughing when I saw that. Like, I get it. I get what they were going for and why they did it. It just, I don't know. It didn't land well for me. Now, with that said, it's probably a feature I'm going to use, because this kind of compressed syntax is kind of nice in some cases. And actually, let me look real quick. I think we actually added it. Primary constructors. Ha! Yes. Boom. There we go. Yeah, so in your sample there of public class string bar, which is, public. Got a typo there. Or a bug. Just gonna quickly screenshot this real quick because that needs to go to a particular team member to fix. There is these things here do end up generating those fields behind the scenes, and just with the way the compiler sets things up, they are only assignable outside of the constructor. So you functionally get kind of a read-write level field. You can do initialization with it, with the properties and whatnot, to be able to go through and set it up. So when I say it's the inverse of read-only, I don't mean the read-only keyword. I mean functionally it's backwards, in my opinion, which again was just one of those things that from playing with it, I just thought was hysterical and went, oh, that's funny. So there was that. Yeah, but worth, again, I think it's a feature I'm probably going to end up leveraging. Like, I wish I had some level of control of these and I could like have them declared with the read-only modifier and all that stuff. Like, I get it. Like, I want a level of customization that's not there. And with C#, what we've seen happen repeatedly over the last several versions is they introduce a feature. It's somewhat limited in its initial release because they can only get so much done in a year. And then they start adding on to it and it becomes a more full-fledged, more useful feature in future releases. And I suspect that's what we're going to see here, is that this is what they could get done and get done well in an initial release. And we will potentially see improvements to have it not feel, just kind of smooth off those rough edges of things. Yeah, and a bit confusing for those that put underscores on their fields. Yeah, I'm definitely I'm definitely guilty of it. And yeah, you're right. It starts to look weird. And we have a version, so in Teletech, the company I work for, we have a set of coding guidelines, and features like this wreak havoc on it because there's not a good, like, there's no good answer of what to do. Like, even with records, we had the same problem of how do you name the positional parameters in a record, because the positional parameter is used for constructor parameters as well as properties. Well, shoot, those had different naming conventions previously, but you've got one thing that's being used in two places. Crap. Like, that doesn't work anymore. And it's the same thing here. You've got one thing that's being used for multiple things, and so you have to basically pick which thing you're willing to sacrifice more. And one option is just don't use the feature, but it's like, well, it's kind of a convenient feature, so it's probably getting used for what it's worth. So, okay, there we go. Now I'll wrap it up, because that's where we were going. Thank you everyone for coming and hanging out. Hopefully that was useful. Like I said, I plan, as soon as I get the updated NuGet key, to roll out the Material Design 5.0 release soonish, or at least get betas out so that people can play with my new tree view. If you do play with the tree view, please drop me a comment or a message, or let me know how it goes. Even if it's, hey, I tried it and it worked well, that's useful data points for me. So I am going to start pulling it into a couple projects and see where it lands, because I think it's pretty good. It's pretty good. I don't doubt that there's things that have been missed or probably could be dealt with, but I think it's probably going to work for like 80% of people. So if you want a tree view and you want it to support things like multi-selection, I got you covered. So as always, everybody, happy coding. See y'all next time.